how did 2022 stack up temperature-wise in comparison to past years?
Well, per NASA analyses, 2022 has tied 2015 for the fifth warmest of all time.
And when you say all time, how far back does that go?
Oh, just really to the mid 1800s.
So when you're looking at the past 10 years, because obviously one year doesn't make a huge difference, but the past 10 years, how is that looking in comparison to past decades?
Okay, so the past 10 years, at least 9 of the past 10 years are in the top 10 of all time in the sense of the record that we've collected. And of course, the year to year variations kind of go up and down. But the important thing in terms of this kind of analysis is really the long term average trend. And so while, say, this wasn't as warm as 2020 itself, the general trend over the past several decades has continued to increase. And like I was saying before, we're now in the thick of it and having the last decade or so be the warmest decade of all time.
How is this information gathered?
So the analysis that we're sharing today comes from an order of like 25,000 stations on ground. And then those plus a couple of different oceanographic buoys and so forth. So it's all data that have been collected by people using instruments that we can touch and calibrate. It is not from satellites, although our satellite record matches very, very well with it.
Yeah, I was going to ask you about the satellites because there were a couple of new satellites this year, correct? How do those play a role in
Yes.
how information is gathered, and what's kind of their role in gathering weather information?
Sure. Well, so there's this NOAA NASA partnership for a number of different weather satellites, and that's been happening for a very long time. And then there's the fleet of Earth observing systems that NASA puts up into space too that contribute to various aspects of this. So for like the analysis out on the street now, the newest satellites that we launched are contributing data per se to that exact analysis. But more generally speaking, these are the eyes on the sky that fill in all of the gaps from the information that we just can't collect on the ground or from a ship or from an airplane. I mean, we'd all love to be everywhere all at once, but it's just not possible on a planet of this size to be everywhere at all times. So with satellites that never get tired, never get sleep, and kind of act as time machines, we are complementing all of this extra information that we're collecting on the ground. And the time machine part is really cool because I love to correct things I've done in the past. But with a permanent satellite record, if you come up with a new idea or you want to test a new hypothesis, you can reprocess the time series repeatedly and see what you learn from doing so.
So you are an oceanographer.
Yeah.
How do the world's oceans feel about this warming climate? What's the impact on the oceans?
Well, it's a really beautiful mosaic of interactions between the ocean and the atmosphere, and land, of course, too. But the way this is all connected is you have atmospheric heating and cooling that are driving ocean currents. Ocean currents are changing, they're fueling productivity in the ocean. What we're really seeing now is that the ocean heat content has increased substantially, and I believe it is at its highest recorded value this year as well. And so the ocean is basically the greatest absorber of energy that we have on the surface of the earth, and it gets transported around, but that heat is not going away. So it's either going to contribute to melting an ice cap or redistributing into places that are not typically warm, increased evaporation, or release of heat back into the atmosphere, which will continue to fuel a rising temperature portfolio. And then, of course, like everywhere else, the oceans are seeing their own extreme events.
And you are doing research on it, correct? I saw that you were working on a project called PACE. Can you tell me about that?
Oh, I love that question so much. Yes, I am the project scientist for the upcoming NASA PACE mission, and it stands for Plankton, Aerosols, Clouds, and Ocean Ecosystems. So while, not terribly catchy, it does indicate that this is a multidisciplinary mission. We're capable for land as well, but the punchline is this is advanced measurements of sea and sky. And while it's very, very capable of studying atmospheric aerosols and clouds and land processes, its real reason for being is to understand phytoplankton community structure. So these microscopic aquatic algae that operate just like land plants, contribute to global carbon transport and exchange with the atmosphere, contribute to the oxygen we breathe, fuel, the base of the marine food chain. And it's a observatory of three instruments that just doesn't exist anywhere else. It's not being planned to be replicated, one of a kind, and it's going to fill this beautiful niche of our understanding of our home planet. So obviously, I could talk endlessly about this, but I'll pause for a moment.
Well, going back to temperatures, what do you see
Sure.
for future?
Rats.
Yeah, it's okay. No, the ocean's taking the brunt. I get it. So going back to those temperatures, what do you see for future years as far as global temperatures?
Well, unless we do something to change Earth's warming climate, we should expect more of the same. You know, we build our cities and organize our farms under some assumptions of resiliency, and part of that is assuming that climate is stable. And I think we've all experienced that the climate for which we built all of our infrastructure is not necessarily the climate we're living in now. And you know, can be seen through droughts, intense hurricanes, rainfall, changing agricultural patterns. So it's not all doom and gloom. You know, we can be smart and make good decisions, and you know, things that we do now will impact what, you know, years from now look like. So just say, be involved.
How much hope do you have in climate restoration efforts being made and new technologies?
Speaking for myself, I prefer to be hopeful. So, I mean, you know, reading the news, you can see, you know, terrible things that are happening, but you can also see innovations and ideas and steps in the right direction. So, I'm going to be glass half full on this. You know, it's wonderful to be part of, you know, the NASA NOAA family, where we can make a contribution to this through the measurements that we make, and you know, talking to folks like yourself and getting the word out. So I'm going with hope on this one.
Sounds good. All right, Dr. Jeremy Werdell, that's all I have, unless you have anything else you want to add.
No, this is great. Thank you so much for your time. Thank you for letting me talk about PACE, as well as the amazing things that NOAA and NASA are doing together. I really appreciate it.
Of course. All right. Well, thank you so much. And